Okay, well this problem looks absolutely terrible. In fact, I've worked it out with a couple of you by hand, and you found out that, it's not a whole lot of fun. It's about a page worth of work. But the problem says, okay, we have this equation here. It represents the surface area of a honeycomb, and the inputs, the things we need to know in order to calculate it, would be this h value, where h is the height of the honeycomb, in this case 2.4 inches. We'd have to know what s is, which happens to be this dimension down here of the honeycomb. That's 0.75 inches, 3/4 of an inch. And then we would have to know what theta is. And theta is going to be this angle inside, and it's going to be measured from 0 to 90. We can't go any less than 0. We can't go any greater than 90 degrees, a right angle. And so it says, what value of theta gives a surface area of 12 square inches? So in other words, that means we're going to take this equation here, and we're going to put in 12 for s, and we need to solve for theta. Well, this is absolutely horrible if you do it by hand, but on the graphing calculator, it turns out it's not too bad. We're going to enter in two equations here. The first equation is going to be y1 is equal to 12, right? The left side of the equal sign. The right side of the equation is going to be everything that goes in y2. So I need to do a few calculations first because I don't want to type it in exactly like it is. Let's figure out what this value is first. So off to the side, I'm doing 6 times h times s, which is 6 times, h is 2.4, and s is 0.75. And this is just for simplicity for me because I don't want to go through and type this in over and over again. It turns out that 6 times 2.4 times 0.75 is 10.8. So this thing here can be replaced by the number 10.8 plus, and I'm going to go ahead and do 3/2 of 0.75 squared. That's 3/2 s squared. 3 divided by 2 is this, times 0.75 squared. That's 0.84735. 375, excuse me. And now all I have left is this stuff inside the parentheses. That is the square root of 3 minus the cosine of theta all over the sine of theta. Now there are a couple of things that I need to do whenever I go to graph this. First of all, I know that my calculator needs to be in degrees mode because I'm going from 0 to 90. This also tells me the window that I'm going to graph it in. So I'm going to go type this in. Let's go ahead and change the mode real quick. Hit mode and switch down to degrees. My window is going to go from 0 to 90. Make it go up by 15s or something like that. I don't care. And as far as surface area goes, since that's the y, I need to make sure I have at least 12 here, right? So maybe I'm going to go like, I don't know, 10 to 14 or something like that. Just a little bit above and below 12. That's why I chose those values. Time to type in the equation. Y1 is 12. Y2 is equal to, and I've got this written off to the side, 10.8 plus, plus 0.84375 times the quantity, square root of 3 minus cosine x. And now I've got a problem here. See, I need to make sure that when I type this in, that this numerator is chunked together on my graphing calculator. So I'm going to go back. I'm going to enter another parenthesis right here before the square root of 3, and another one after the cosine x. That way, okay. So now look, this set of parentheses is working for the square root of x. This set of parentheses here is for the cosine of x. And then this outer set of parentheses that you can see here, barely, if the glare is not too bad, this outer set of parentheses now chunks the numerator. So I'm going to take then and divide that whole thing by sine of x. There ends the x, the sine function, and then this parenthesis here ends the one that goes in front of the 0.84375. So that was a lot of parentheses, wasn't it? We've got to make sure those parentheses are correct. Now, time to graph. There's the y equals 12. I'm interested in where these two lines meet up, and it looks like it's going to come down and... Now I have a question here. I can't tell by looking at this graph. I don't know. Does this thing, like if I was to zoom in, does it come down and not meet it at all like this? Does it come down and just touch it and go back up? So there's one solution, because this is a no solution case. There's a one solution. Or does it come down and go like this where I have two possible solutions? Maybe it dips down below that line. Well, I can't really tell from this view, so I need to zoom in a little bit, don't I? And so I'm going to use this zoom button, and I'm going to use the zoom box feature. So I'm going to hit enter here. And the box that I want to zoom in on is going to be somewhere between, I'll scroll up to the top left corner and hit enter. Now I'm going to scroll to the right and I'm going to scroll down. You'll see it in just a second. There we go. Here's the box that I want to zoom in on. Now when I hit enter, this is going to zoom in on that little portion. There's the first line. Aha, it dips below, doesn't it? It dips below the line. So there's going to be two solutions to this problem. The two solutions are at second, calculate, find out where they intersect, just like in the previous video. I'm going to scroll to the left. I'm going to hit enter, enter, enter. It's going to be somewhere over here. Look at that. 49.9 degrees, 41.91 degrees is the solution. Or the second solution is going to be farther to the right, so I'm going to do second calc intersect again. I'm going to go to the right over here somewhere. I'm going to hit enter, enter, enter. 59.86 degrees is also a solution. So there are two values of theta that will give us a surface area of exactly 12. Those are the two angles. Now, the last question says what value gives the minimum surface area. So minimum is the key word here. We're looking at this parabola-like shape. We want to find the lowest point. Easy way to do that is just to say second calculate the minimum. It says left boundary, so I need to go to the left of the, oh, by the way, I'm going to hit the down arrow to switch to this one. Somewhere here. And watching this. Looks like it's going back up, isn't it? So here, hit enter. The minimum is at an angle of 54.74 degrees. Now, if you want to do by hand, more power to you, but I would suggest using the calculator here to get the answers that we just got.